Yeah, hi everyone. I hope you had a good week so far, catching up with the KNN lectures. So there was this one more lecture that we had on improving KNN, and then the one lecture on implementing KNN in Python using scikit-learn. So I decided to make another video. I was reviewing your quiz, the intro to getting to know you quiz, which I really appreciate that you all answered. So I really liked reading about your experience, so I can also a little bit tailor the course to your experience. And it seemed like most of you, or all of you, have a programming background or had taken a programming class before, which I think is very useful for taking this class. But I would say only half of you have solid experience with Python. So before we start scientific computing with Python next week and also looking into scikit-learn a little bit more, I thought it might be helpful for those who are, let's say, a little bit more new to Python to give you some help with setting it up so that next lecture will go more smoothly for you. Yeah, and also as a fun fact, I was reading through your favorite hobbies section. Like I mentioned, I like cross-country skiing in winter and running in summer, and I really like hiking also. And I try to spend as much time as possible in summer outside in nature if time allows. However, there are often many rainy days and there are also long winters here in Madison. So similar to some of you, I also like video games, and also there was at least one student who mentioned the Zelda series, and I think I didn't even miss one single entry in the major series of this gaming series. So that's something I really like to do on or during Christmas when it's really snowy outside, you can't go outside, and let's say you had a very busy, stressful, productive day. It's kind of a nice thing at the end of the day to relax a little bit. Anyways, let's get back to the lecture. So like I promised, this lecture will be an optional lecture. If you have a strong Python experience or you already have Python set up on your computer, it's not necessary that you watch the following 3 videos. It's really more for the students who have not worked with Python on their computer. So in that way, I can maybe give you some, not motivation, but also some advice how I use Python. Of course, the way I use Python is maybe not the way you want to use Python. I'm just giving you some examples here from my experience. So and also after this lecture next week, we will have the first real homework. So I had like these small quizzes. However, these were more like self-assessment quizzes to see whether you followed the lecture. However, to really better understand how certain concepts explained in the lecture work, it's very helpful to implement them. So I will prepare a homework for next week where you will be toying around and implementing a k-nearest neighbor algorithm. And part of it will require you that you write your own code, not only using scikit-learn. So in that way, it would be helpful for you to help yourself to set up Python this week, and then next week I will tell you about NumPy and a little bit about the scientific computing libraries, which you will then use for implementing KNN. But don't worry, this is not a very hard homework, it's the first homework, right? So it's more about helping you to understand the KNN lecture. And after we've done that, then we will go back to some more conceptual machine learning aspects. So before we start, to just give you again like a short overview of where we are in this course. So we covered the introduction in the first week, and we are currently in the second week talking about the computational foundations. So the introduction was like just a simple intro to ML and the KNN. And after our computational foundations, we will go back to more like core machine learning topics. However, for these core machine learning topics, I have homeworks in mind that I want to make, where I will ask you to use some of the computational aspects that you learn about in part 2 to implement some of these ideas and concepts here, which is why the computational foundations come so early in this class, so that you can use them to really toy around with these ideas. Yeah, and in particular in part 2, this lecture is this lecture on using Python, and this is optional. So you don't have to watch it if you have Python all set up. If you have a new version of Python, 3.7 or 3.8. If you have something like Python 2, that's a very old version of Python, and you may want to watch this video to just get an idea of how you can set up the recent version. And also there will be a tool required. You can use either Jupyter Notebook or Jupyter Lab. So we will be using these for the homework. If you have no idea what that is, you can watch the third video of lecture 3. The first 2 videos are very basic, and the third video I will give you some idea how you can install Jupyter Lab. Yeah, this will be a rather unusual lecture because it will be more interactive. So I'm not going to use slides this time, but rather type here in some basic text file. So I'm just going to type some basic keywords just to help us, seeing where we are in this lecture. So the lecture 3 will be primarily about using Python. And I will start by giving an introduction to Python. And then I will show you how we can set up Python. Like, I will show that on my Mac computer because I have a Mac. I don't have a Windows computer, unfortunately, where I can test this on Windows. However, if you have any questions about that, our TA in this course has a Windows computer, so he will be happy to help you with any Windows related questions. But I think it may still be useful to go over the basic concepts on, let's say, my Mac computer, even though you have a Windows computer. Yeah, and like I said in the beginning, you don't have to be an expert programmer to use Python. Of course, in certain applications, you may want to be an expert programmer, software engineer, computer scientist, and so forth. But for this class, we are just using Python for machine learning. And I think it is already sufficient to learn some of the basics in order to follow this course. You don't have to know everything about Python. I mean, even I used Python like for 10 years or so. I don't know everything about Python, and I also don't need to because I'm more like researcher. I'm not a software engineer, at least not yet. So in that way, we are just focusing on some basics of Python. But yeah, before I go on and on about that again, let me just get started by talking about Python itself. Yeah, so Python is an interpreted and dynamic programming language. Let me also remove maybe the setup for now because we're not in the setup right now. We'll talk about this later. Python is a dynamic and interpreted programming language. And for example, another language that you may have heard of is C, or maybe even C++, C#, or Objective-C, and so forth. And C is, for example, a static typed language. Or I can also say statically typed. It's like a language with a static type system. And this has some implications with regard how we use the language. So the advantage of Python is really that it's more interactive. It's interpreted and dynamic, so that kind of implies it's somewhat more active or easier to use. It's very similar to R in that way. If you have used R in other statistics classes, and I'm 99% sure that you have. It's very similar to R in that way and very, very different from C, although C is used to implement Python. But yeah, C would be something you would use if you have to implement something very efficiently. One disadvantage of Python being interpreted and dynamic is that it's relatively slow, but also in machine learning, we don't really have to worry about it that much because, as we will see in the next lecture, in lecture 4, most of the scientific programming libraries or computing libraries will be using C or Fortran code under the hood. So Fortran is another statically typed language that was very popular in science like 50 years ago or something. It's still very popular because it's still used under the hood, but it's just more work to write code in C and Fortran, and it's also more work to kind of run the stuff. So if we run some computations, it would be way more work if we want to just get some quick results to do that in C on Fortran, which is why Python is quite convenient, and it's also an all-purpose programming language. So with that, I mean, we can do all kinds of stuff. I mean, I know people who use Python for their web frameworks. Just on top of my head, I think Instagram, Dropbox and stuff are implemented in Python. There are many people using Python very extensively for various different things. I think even YouTube, but maybe they've changed it. I don't know. I don't know the details anymore of what people are doing at these companies. But back in the day, at least YouTube, I think, was also based on Python for some time. But I don't want to say anything wrong here, so don't. So take that, at least the sentence, with a grain of salt. But yeah, before I go on talking about interpreted and dynamic languages, and statically typed languages, maybe let me show you an example. I will just maybe code a simple example in C first, and then I will show you how much work that is, and then I will do the same thing in Python. So then you will maybe appreciate why we use an interpreted and dynamic language in this class. Yeah, so the program that I'm going to write is maybe something very simple, like printing a string like ABC equals C, and then maybe A plus 2 equals 3. So this is something the program has to evaluate then. So it should be a 3, but I won't tell the program. I will just write a program to do this simple computation. So I will use my favorite text editor for doing that, Visual Studio Code. It's right now my favorite text editor, but of course I switch text editors a lot. Anyways, I will talk more about that also, I think, later in this lecture. Let me just write the quick C program that does like the A plus B plus C equals C, and the 1 plus 2 equals hopefully 3. Let's call that example.c or something. So we'll just call that example.c. And first in C we have to use a header file. Usually it has some basic functions. It's just a header file here. And then I would write my main program. So in C we usually have a main program. It's kind of funny because when I learned Python in my undergrad studies, also our professor, he was mainly a C programmer, and we always had to write a main function in Python. So later on, when I took a C++ class, I kind of learned where that was coming from. Anyways, so in statically typed languages, we have to declare our variables. So I would have, for example, int result. So that's an integer that is then storing the results later of my 1 plus 2 calculation. What else do I need? I need a character vector. So I call that maybe word. It's just an array, character array. So characters for the characters in the letters here. It's because we want to print this one. I think I just need a 5 here, right? So that's what I want to print here. A plus B equals C. And then I have my result. That is the result from my computation that I'm caring about. I have a 1 plus 2, right? And note, really, that is why it's statically typed. I first have to declare the variable. I have to declare the variable result, which is an integer variable, because this will be an integer. And then this is for another thing I will do. I think I need a semicolon here too, right? And here too. And now let me print the character vector. It's like some very arcane stuff I'm typing here. Oops. But we can use the same stuff in Python actually. So this is like this typical string formatting format. So we have, this stands for a string, and this backslash n is like a new line character. So we are printing first our thing here. And then what we are doing, we are just maybe printing the result, and then we're done. Let's print f and just the result without anything. Always forget the semicolons because you don't have to do them in Python or R. And yeah, so I'm a little bit rusty on my C programming here. And then let's finally return 0, which is also another convention in C. So now all we have to do is we have to save the file, and then we can hopefully execute it. Let's save it. But yeah, executing it, it's not so simple because it's a statically typed language. We have to compile it. It's like an extra step. So I can't just run this code. I can't just go to my terminal. Let's let's go to the desktop where I saved my example C file. I can't just run my example.c file because, well, okay, it also shows some weird permission issue, but it's not like a file or program that I can run yet. So what I have to do is I have to compile it first. So it's an extra step that we have to do. So we have to compile it, and we will call the program, maybe just example for simplicity. So we'll compile this example.c file to the program example. Let's do that here. Okay, it's doing some fun stuff here. Forgot the semicolon. So the compiler is throwing an error here. Let's compile it again. There's some warnings, but I think it should be fine. So again, we are still compiling it. So it has compiled, and now we have a program called example. So you can see it here on the right side. Maybe I should make that a little bit bigger. So this program that we just have compiled, or that we have just compiled, we can execute that right now in the terminal, and we get a segmentation fault. And I think this is because I use a character vector of 6 and 5, and I should have used 6. I think that's why. Let me just try this again. Yeah, see, that's like a lot of hassle. So we have to compile it again. And nope, I'm still giving a segmentation fault. I think that's maybe because I didn't do the proper string formatting here. Or at least, yeah, the print command. Let's try this one. Yeah, you can also see doing that live is a little bit weird. Yeah, that works perfectly now. So yeah, I successfully printed a string and printed the number 3, i.e. carrying out the computation here. And you can see, I mean, just based on my workflow here, that this is a lot of work, right? So maybe we can just use Python to do something simple like that way more conveniently. For that, I don't even need to set up some script and compile it. I can just use my interactive interpreter. So I'll also show you how you can set it up in a later video. But for example, I will just enter my interactive Python session here, and I can just, I don't even have to declare a variable here. I can just type it, and it will know that result is an integer because I'm adding 2 integers here. So I can just show the result here, or I can also use print. It's not even necessary in the interpreter. And then similarly, if I want to get my string, I can just type a plus b equals c, and I can just print word, or just execute word. Also note there are a lot of different ways to print something in Python, the string formatting. I can use the same thing I used in C, like doing it like this. And also, instead of running this in our interpreter, we can write a Python script. This is usually useful if we develop more complicated code, or if we want to share our code and stuff like that. So I can also write a script file, example.py. And I can just do the same thing I did in, oops, it's giving me advice here. It's cool, right? Anyways, word, let's call it a plus b equals c. And then printing just the result, and yeah, you can see it's making suggestions here while I type. So Visual Studio Code is actually pretty handy for Python programming because this is all the additional help here in case we need it. And then once I've done that, I can just run the script by calling Python example.py, and it will run that. And we don't have to compile anything. We can just save and then run it. There's also a way you can just run it here. I think it should, oops, yeah, it should also run it here. Usually I'm traditional, I just use my terminal for that, but you can also just do it in Visual Studio Code. It's maybe easier. One disadvantage though, when you're running Python code, is that things are evaluated at runtime, except like syntax errors. Let me show you what I mean. So if I have something like if some condition, and then I have something like text equals, I don't know, ABC plus 1, 2, 3, and then else text equals ABC plus, let's say, I don't know, something like that. Oops, I am not sure what button I pressed here. Okay, so if I have something like that, I should maybe define the condition. Let's say false. So if condition is false, it will execute this one first. Let's quickly do that. Okay, it works because there is no issue here. However, this part here is kind of illegal in Python. You cannot just add a number or integer to a string. If you wanted to add this, you would have to do this. Oops. I'm sometimes pressing a wrong button here. Right. So you would have to do this. And this one is not okay. So Python is not telling us about it, though. It's executing the code anyways. However, this can cause issues if you have very complicated code. Let's say you are Instagram and you implemented some very complicated API, and there's some rare case where some else condition or if condition gets triggered. It's very rare, maybe it only happens, I don't know, once a month or something. So if you deploy that code, you will likely not know that there's maybe a potential error. However, if some user uploads a certain thing and it triggers a certain condition, then it may cause an error, and then it's pretty late because then the user gets annoyed and stuff like that. So that's one disadvantage of Python. So this one is only executed or evaluated if it's executed. So if this condition is true, then this would be executed. The if condition will be executed. So if I do this, now we get a type error here, can only concatenate string, not integer to a string. So yeah, that is a little bit annoying, right? But yeah, that's one downside of Python. However, we get all the convenience that things gets executed without a compiler. All right, so enough about compilers and stuff. Let's talk about how we can set up Python